All right, hello and welcome back to the branches slides. Let's finish them up. So we ended talking about how to combine two Boolean expressions with the AND operator, and I want to give us some more practice with that. So here is my silly example for us today. Let's ask the question, should I bring an umbrella today? And one way to determine whether or not to bring an umbrella is if both of these questions are true, right? If it's both cloudy today and there is also a chance of rain, right? So if one of these is not true, then it doesn't really make sense to bring an umbrella, right? So that's something we can do. We can make both of these in code and then combine them using AND, which is 2 ampersands, okay? And so if they're both true, then we can output like bring an umbrella. Okay, so let's code that up. And remember that the result of an AND is only true if they're both true, if both sides of it are true. So let's be like, I'm going to get strings. I'm going to get words from the user, so I'll include the string library. So is it cloudy today? And is there a chance of rain? So we're going to ask both of those questions. So string cloudy and string rain. So we'll have both of those at our disposal. So we got to first get this one, cn, hey, is it cloudy or not? The user can type like yes or no. And then we'll cn, hey, is it raining or not? Or is there a chance of rain? So I made both variables, and now we'll get them both. And then we can do stuff based on those. So if it's true that it's both cloudy and there's a chance of rain, that's when we want to bring an umbrella. If both of these things are true. So if it's cloudy, so the user typed into this variable, hey, is it cloudy today? They typed yes or no. So if they typed yes, and if they also typed that it was there was a chance of rain, if they typed here, yes as well. So if cloudy was yes and rain was yes, then we should bring an umbrella. Okay. Otherwise, if that was false, we can be like, don't bring an umbrella or something. There's no need in that case. Okay, so do you see how this is working? That is important. So let me compile and run this. Boop. Is it cloudy today? Let's say yes. Is there a chance of rain? Yes. So we want to bring an umbrella because they're both true. But if any of them is false, like if it's not cloudy but there is a chance of rain, then maybe the other people got it wrong. So we'll just say don't bring an umbrella. Or if it is cloudy but there is no chance of rain, still no need to bring that umbrella. It's false. And then if it's not cloudy nor is there a chance of rain, still, of course, no need for that umbrella. So only is this true, only is the AND true if both sides are true. Okay, so that's one way to combine conditions. There are more. Let's talk about the others. Let's talk about OR. If you have two pipe characters, that stands for the OR operator. Oops. So OR. And so here's another thing that we might want to ask if we want to bring an umbrella. Hey, is there a chance of rain? Or if we look out the window and see if it's currently raining, even if the weather people got it wrong, we still want that umbrella, right? So we'd like to ask, hey, is one or the other true? Right? Or both. Both is okay. That's what we want to be able to do. So to ask that kind of question with an OR. All right. So the OR operator, those two pipes, right? It is going to give back true if either side of it gives back true. So no matter what, if one's true but the other is false, they're OR of them. Hey, is A or B true? Yeah. Yeah, the answer is still yes. You see that? The only time that A or B is false is when both of them are false. Hey, is A or B true, either one of them? Sorry, neither. That means it's false. Okay? So that's how you do that. And so let me show you this program. Let's make a new umbrella program and combine these conditions with OR. So I'll copy all this, actually. Umbrella tool.cbp. So what are we asking? Is there a chance of rain? And then we'll also ask, is it currently raining? So let's chance. They both have rain in the words. Let's have multiple variables. So chance of rain. Is it currently raining? All right. So if either of them are true, one or the other, or both, then we want to bring that umbrella. So if chance of rain is yes, or currently raining is yes, in either case, especially if both are true, we want to bring that umbrella. Okay, so that's a different way to combine conditions. Oops, umbrella 2. Is there a chance of rain? So yes, it doesn't matter what the next one is. If I already said yes once, bring an umbrella is true because one side of this or was true. Same with no and yes. Is it currently raining? Yes, bring that umbrella. And if both are true, yes, yes, still bring an umbrella. One or the other is true, definitely. The only time it's not true is if neither is true. So that's the one time where you don't have to bring that umbrella, when both sides are false. Okay? So that's the or operator, which is super useful. It's also very good for like picking different options that don't overlap. Like if you want to do something, like here's a number line, because usually we do stuff with numbers, right? So if you want to do something based on whether or not your number is within this range or when it's within this range, the or operator is a great case for that. Okay? So that's or. Let's talk about the, I guess let's do the last one too right now. This is the final operator that I want to show you right now. It, the last Boolean operator at least, it only takes one thing, and it's the exclamation point, and it makes the opposite condition. It's also called negation, okay? Because sometimes we want to ask like, hey, it's easier to ask at least, when something is false rather than when something is true. This negation operator, this exclamation point, makes that possible, okay? So you just say not. You read it as the word not, by the way. Not, that's how you pronounce it. So if you have a variable a and you say not a, if a was true, it makes it false. If a was false, it makes it true. It just flips it, negates it, we say, okay? So it's useful sometimes to think of things in terms of when they're not true rather than when they are true. Sometimes it's easier to formulate that. So here's a fun little example that will be useful for you later in your computer science career. I think I already talked about this a little bit. If you want to check the opposite of is A less than B, you can negate that. And that is in fact equivalent to checking if A is greater than or equal to B. Does that make sense? So let me show you why that's true. So here are some options for A and B, and A less than B, and the negation of A less than B, and A greater than or equal to B. This is the opposite of this. And I want to show you that these are equivalent. So I'm going to draw a fancy table with some options to hopefully prove that for you. These columns are going to end up being the same for my example. So let's try A is 40, B is 42, A is 42, B is 40, and then they're both the same. Like, let's just do 42, 42, 42. So A less than B, for these values of A, well, that's true. For these values of A and B, well, that's false because it's bigger. And it's not strictly less than, so this one's false as well. Okay? And so taking this and negating it, true becomes false. False becomes true. So we have false, true, true. And then that is going to be equivalent to A greater than or equal to B. And let me show you that. So is A greater than or equal to this B? Nope. Is A greater than or equal to this B? Yep. Is A greater than or equal to this B? Yep. And so these correspond. And that was a hand-wavy proof, but it is mathematically true. All right, these are equivalent statements. Sometimes it's easier to use the not operator, okay? But it is sometimes you can get rid of it as well, and you have like a different relational operator to use. So that's the not, and it will negate a condition. Okay? So that's what I wanted to show you there. I think that's all I wanted to say. So next I want to talk about this concept called precedence, which is going to be very important now that we know a bunch of operators. Okay? Because one day you're going to write a huge condition with like some pluses, some stars, some less thans, some ands, some ors, like all together at once. And so it's very, very important for me to teach you how C++ is going to evaluate a big long condition like this. In which order is it going to work on the sub-problems first? How is it going to draw those parentheses around things, right? What is the order of operations for C++? And we call that order of operations precedence, okay? Which operations precede others, okay? And so what I'm about to show you, there's a table. We're going to look at it. But the gist of it is, in order of precedence, there is an order. Every operator takes the smallest thing it can to the left and the right of it, and that's how it evaluates. That's where it draws its parentheses. So C++ knows like the rules of arithmetic, like if you say 5 times 7 divided by 3 plus 4, it knows to do like this first, then this. Like that's the way it's going to draw parentheses. But there's like stuff that we don't know about yet, like how do you draw parentheses around a less than and an ampersand. Oops. Let me draw some better ampersands there. B less than C, or C mod D equal 42. Like where are the parentheses going? Like we have no clue. So let me teach you that. All right. So there is a table that tells us how, and here it is. And I'll give this to you in the slides, in addition to the slides for today. So here's the big long precedence table. Here is stuff with higher precedence up here, all these boxes. Everything in the same box has the same precedence. You just do them from left to right. But this stuff happens first, before this stuff, before this stuff, before this stuff. And then these are things that are done later because they have lower precedence. Okay, so you find the first thing in your expression. Which operator can you find first in the as high up in the table as you can? Okay, so like here's multiplication, here's addition. Like multiplication and division happen before addition and subtraction, right? Higher precedence. And here it is spelled out in the precedence table like that. So let me show you some examples of using this table, and then this rule should make sense. Because in order of precedence, each operator grabs the smallest thing it can to the left and to the right of it. Okay, so let me show you that in action. So here is my first example. 5 times 7 mod 3 plus 4. So what you do is you go and you look in the table for all these operators. These 3 are the ones we have. Where are they in the table? Here's multiplication, here's remainder. They're at the same level, so you just do them from left to right, that's fine. And then the addition is below both of those, so addition happens last in this example. Okay? So these 2 operators are at the same precedence level, as high in the table as we can find, and so they're going to happen first from left to right. So the multiplication is going to happen first. Okay? And what it does, the multiplication operator is going to take the smallest thing that it can to the left and to the right of it, and that's how it will draw parentheses. That's how it knows what to work on. Okay, so it's going to say, okay, what's to the left of me? How many things can I take? The fewest number of things possible. There's only one thing to take, so it'll take the 5, and that'll be the thing on the left of the multiplication. And now notice that we have options of where to draw the right parenthesis. Could be there, could be there, could be there. We take the smallest amount of things. Okay, so we're only going to take the 7. That's what this rule means. Smallest thing it can to the left and to the right of it. So it's going to do the 5 times 7 first. And then we only have 2 operators left to worry about. And remainder happens before addition. So we worry about this one. It's going to take the smallest thing it can to the left and to the right of it. This is now parenthesized, so it has to take the whole thing. And then it's not going to take the 4. It's going to take just to here. Okay, that's the smallest thing it can take to the right, to the left, and to the right of it. Okay, and then we're done because the plus has only one thing to the left and to the right of it. You don't have to draw that last set of parentheses if you don't want to. It's going to take this and add them together. Okay, so that's the first example. And now let's do this one. All right, let's make it happen. So let's find all the operators. You got this one, this one, this one, this one, this one, and this one. Where's the first one in the table? All right, so let's find them. Let's see here. We have, I think it's modulus. You got your modulus, and then the relational operators are way down here after arithmetic, and the and the or are even after those. So it looks like remainder is happening first. Okay, so this is going to take the smallest thing that it can to the left and to the right of it, and then we're done. So it's going to take the C and the D. It's not going to take like the C or the C. It's not going to take the D equals 42. It's just going to take the C and the D. That's the smallest thing it can take to the left and to the right of it. Okay? And then we have our other operators. So we have relational ones, and then some ands and ors, and those relational ones happen first. So here is the less than, greater than. Those happen before the equal to's, it seems. So we're going to do the less thans from left to right. So this is the first thing that's going to take two things, the smallest things it can to the left and to the right. So it's going to take just to here, not to here or anything like that, right? Just to here. And then this one is next. It's going to take these two things, the B and the C. And then we have and or and equality left. And then it's equality that wins out. Equality, then and, then or. In that order. So the equality takes the smallest things it can to the left and to the right, so that one and that one. And then and takes its things, because it is above or in precedence. And then the or is the last thing. It's going to or together this big result with this big result. You don't have to draw those final parentheses. Okay? Does that make sense to us? Do you see how I'm reading this off the table? This is very important to know, because one day you're going to write something that looks like this, and I want you to be able to parse it in your mind. Okay? The biggest thing that's going to trip you up one day might be the and the or. Okay? Yeah. So with that in mind, try both of these. Try 1 and 2, and then I'll do them with you. So assume that x is equal to 5 and b is equal to true. All right. So see if this one evaluates to true and or false, and see if this one evaluates to true or false. And I want you to do it in your head. Don't do this in C++. That's not helpful for you to do right now. So try it in your head. Draw the parentheses. Execute these statements. Right. So give that a try, and assuming you're back now, with x being 5 and b being true, what's going to go on here? All right, so let me just quickly draw the parentheses, because this is how it's going to work. It's going to do those, this, and then the and versus the or, the age-old question, and happens first. We say that and binds tighter than or. It draws its parentheses first. Okay, so that's going to happen there. And then the rest of these, kind of self-explanatory. And this one, I've already drawn parentheses, like I'm forcing this or to happen first. You see the difference? If you want the or to happen first, you have to draw parentheses yourself. You have to make that part of your code. So, and this is actually going to make all the difference, whether the or takes these two things or these two things. All right, and versus the or, age-old question. So here we go. X plus 1, that is 6, always. Is 6 less than 8? Yes. So this whole thing is true. Or that, with anything, the answer is always true, right? So this first one's A. We know it's A. We can do this one too if we wanted to, but this is true. And x greater than 5, that's false. This and is false. So it's true or false, but it's always true, right? So it's the whole thing is true. The answer is A for the first one. So this one's A. And let's see what this one will give back. So this is 6 is less than 8. Yes, that's true. And I guess, sorry, this side happens first. So this is true. Or B, which is true. So the whole or right here, or together, the whole thing there is true. ANDed with is x strictly greater than 5, false. So anything ANDed with false on either side is false. So the answer for this whole thing is false, which is B. See that? That made all the difference, whether or not you did or before and, or vice versa. So watch out for this. I encourage you to draw parentheses yourself in your code so that you're explicitly saying that you understand which one's happening first, or you're forcing one to happen before the other. Okay, that's probably the best thing to do at this point in time. So that is my question for you, and I hope you see that it's useful to know these precedence levels, right? To read off this table. If nothing else, just understand that and binds tighter than or. It happens first. All right. So with that, we have learned about branching. We have learned about relating things. I just want to give you a bunch of examples now, okay? So this can all sink in. The first example is kind of like Hello World for branches. It's something that everybody learns. This actually used to be an interview question just to check if somebody knew how to program. It's called Fizzbuzz, right? So here's the game. What you do is the user gives you a number n, and what you do based on that number n is either print fizz, buzz, fizzbuzz, or the original number. Okay, that's how you do it. So you print fizz if the number that you're given, call it n, is divisible by 3. You print buzz if the number was divisible by 5. And you print fizzbuzz if it was divisible by both 3 and 5 at the same time. Okay? If none of those were true, wasn't divisible by anybody, then you just print n by itself. Okay? So if you were playing the Fizzbuzz game, here are some inputs and their associated outputs. So 1, you just print 1, 2, you just print 2, because there's no divisible, neither of those are divisible by 3 or 5, right? But 3 is divisible by 3, so you print fizz. 4 is divisible by neither, so you print 4. 5 is divisible by 5, so you print buzz. 6 divisible by 3, so is 9, so you print fizz, but it's not divisible by 5, so only fizz. 10, only divisible by 5, not 3, so print buzz. And then once you get to 15, that's the first number where it's divisible by both. And so you'll print Fizzbuzz in that case. Does that make sense? So that's the game. That's the Fizzbuzz game. And so it has to do with checking for divisibility a whole lot. So do you remember how to check for even and oddness? That was, let's see here. That was divisibility by 2, right? Seeing if something is divisible by 2. So, and this is how you would check it. You'd try to divide by 2 and get the remainder. And if it was 0, that means 2 went in cleanly. It was divisible by 2. That's what it means to be even, okay? So even, if true. Divisible by 2, if true. And so following that pattern, this would be how you check for divisibility by 3, right? I can say n is even, if true. So that's how you check for divisibility by 3, and you just swap it with a 5 if you want to check divisibility by 5. Okay, so that's the Fizzbuzz game, and okay, here is one implementation of the Fizzbuzz game after you got the number from the user, of course. Here is an implementation of it, and I claim that this is an incorrect implementation. So please take a look at it and see if you can figure out why it is not correct, why this implementation is not going to do the right thing in every case. Try them all, as many as you can think of and have time for. It's best to run the code in your mind, but you can also code it up. Doesn't matter. So pause the video, give this a try, and see if you can figure it out. All right. So the idea is, what's happening with this code is the following. First, it's checking divisibility by 3. Then, if that's not true, then it's checking divisibility by 5. Then, if that's not true, then it's checking divisibility by both. And then if nothing's true, then it's printing the original number. In that explanation, did you see the problem? Even in words, it seemed wrong. Did you notice where I said something that sounded off? So let's draw out how this is going to execute. So first it'll check, hey, is n divisible by 3? Question mark. If that's true, it prints fizz. If it's false, then it tries this one. Hey, is n divisible by 5? Question mark. If that's true, it prints buzz. If that's false, then it asks, hey, is n divisible by 3 and 5? Question mark. If that's true, it prints fizz buzz. And if that's false, it just prints the original number in. All right. So, did you notice the issue? The problem is down here. the only way we get to check if it's divisible by both is once we know that it's not divisible by either. Do you see that? So this is happening way too late. What's going to happen right now if n is 15? And it should be printing Fizzbuzz. What's it going to do? Well, it'll first check this. Hey, is n divisible by 3? Yeah, sure is. So it'll print Fizz and call it a day. That's wrong. Okay? We don't like that. We don't like that at all. So this more less probabilistic thing, this thing better happen first. We better be checking the thing that's not as likely ahead of time, right? Because this check subsumes this check. You see that? So we better be checking for this one first if we want it to ever fire and print Fizzbuzz. Okay, so let's fix the problem. That means we got to move this guy. This check better be the first check ever. Let's do it. So we'll call it n, like we've been doing, cnn, and now we'll do it right. So if the first thing we need to check is divisible by both, if n is divisible by 3 and n is divisible by 5, then cout Fizzbuzz, and else if, then the rest can go in order. If 3 and 5, there's no overlap. And then we can have the buzz, and then otherwise cout n itself. Okay? So this will work. This will do it right. And sorry, I forgot to save. So 1, 2, 3, 5, 15, we get our Fizzbuzz. Isn't that nice? So it's all about the order in which you try these options, right? Order really matters. Okay, I hope you see that. I don't know if that makes sense. So please yell at me if it does not. But I would like to talk about comparing non-numbers now. So let me show you that. I would like to show you string comparisons, and then also the CC type header, which is useful to talk about. So let's see here. Let me first open up the CC type header. Let me get that ready for us. C++ CC type. Boop. So this is all the functions that exist in the CC type header. Very useful for us in a second. And then we'll do the demos. All right. So the first thing I want to talk about is the ordering on strings. Very weird. They're compared using what's called lexicographic ordering. It's a very long word. All it means is dictionary order. So one string we say is less than another if it were to come before it in the dictionary. So for example, C++ considers ABC to be smaller than like BCD. And if the first letters are the same, if you're trying to compare AAB and ABC still, then it just goes to the first one where they differ, and it looks, hey, is that one smaller? That's just normal dictionary order, okay? But it has to do with weird ASCII values as well. So like if you have lowercase my name, that is, I think it might be bigger than, based on the ASCII value, to my capital version of my name. Okay, so that's going to be something to worry about later. I think 0 is less than the A character, things like that. But it's essentially dictionary order, and you can try it out in code if you ever have any wonders about it. But that is that. My next example is, let us, using the library that I'm about to show you, convert a string to a proper noun. Or maybe in code, let me show you this lexicographic ordering just quickly. I'll just do string stuff, .cpp, for lack of a better name. So I want string And then I'm also going to need CC type in a second. So here is, I don't know, cout hey is the string ABC, is that less than, or for reasons I think I need to put them into variables, x is one less than the other. Cout hey is x less than y. And for precedence reasons, I better put parentheses around these. It was complaining. Okay, yes, that was true. This is smaller. X comes before y here in the dictionary. All right, now, first example. Convert a string to a proper noun. So we want to capitalize. So if you had lowercase my name, then you want to make it capital my name. Okay? And you don't want to touch it if it's already capital, right? So let's convert to a proper noun, and there is a very nice function in the CC type header library that does that for us. There is a toUpper function. Oh, nice. So all you have to do is give it a string, give it a single character, and it gives you back the uppercase character. And it doesn't touch it if it's already uppercase or if it's a number or anything like that. You can read more about it. Like, it's unchanged if it's not an alphabetic character. It's lowercase, but that's what it's going to do. Okay. It takes a character, gives back a character, but for weird C++ reasons, it takes an int and gives back an int. That we won't get into here. Just pretend this is char and this is char. Okay. So let me show you this. So let's be like string s equals lowercase my name. And then to capitalize, what we want to do is use toUpper. So we say s at 0, the first character, right, equals whatever it was, and we can use toUpper. Isn't that nice? That's better than hacking away at the ASCII values. It's already done for us. And sorry, there's no underscore, excuse me. Just toUpper like that. And then this has changed the 0th character, the L, to be capital. And so if I output S, it has been capitalized. Bam. That's nice. All right. So that's one thing to do. The next thing to do is let's make a, let's write some code to check if a string ends with a number. So like we want to see if like this string ABC123 ends with a number. Okay? That's what we would like to do. And so we need to find out what the last character is, and we want to check if that last character is a number. There is a nice CC type function called isDigit that we want to call here. That checks if a character is a decimal digit, which is exactly what we want. So we want to do that. And we want to give to that function, the 3 in this case, which is the last character in the string. And now we need to figure out how to get the last character. Okay? And so if this is your string, if it's ABC123, looks like this in memory, right? Think about indices. 0, 1, 2, 3, 4, 5. How do we know to get 5 out of S? And if it were longer, how do we get the ending index no matter what? Do we have something that we can use here? How do we get the 5? How do we get the last index in any string? Think about that, and then I'll tell you my answer. So the answer is the size. The size here is 6 because there's 6 characters, and so if you just subtract 1 from your size, you get the last index that is valid into your string. Isn't that nice? So that's how we can get the last character, and then we can check it. All right? So let's do this. String s equals ABC123. And so we could do it like this. We could check if the last character is a digit. If the string ends with a number. So if something, then we'll be like s ends with a number. New line. Otherwise, it does not end with a number. And so what do we put here? Well, we need to check. We need to get at the last character of s. S at s.size minus 1. You see that? Calling functions within functions. So s.at gives me a character at an index, and this is the index I want, the last one, whatever it may be. And then I want to see if this character, which I get by calling s.at, seeing if that character was a digit, which I can then wrap around is digit, because it takes a character, gives back true or false, whether or not that character is a decimal digit or not. Oh man, is digit. Wrap that around all this. Do you see that? Let me add some spaces just so that you can see what's going on. The inner bits. Whee! And so, just like that. Okay, is digit of all of this. See that? And then s.at this index right here. So if the last character is a digit, it ends with a number. Oops. I have made a string already called s. Let's I don't know, s2. Or no, let's call this one something else then. Let's call it z. That's easier. Alright, now I can have my s at the bottom now. Whee. And yes, it does end with a number. And if I get rid of, or I add, the a character again, it does not end with a number anymore, because the last character is the a now. And that's what we're getting, because size always gives me the last, the size of the string, no matter what it is, and minus 1 gives me the last index. Go there, see if it's a digit. You see the operations and the order of them? Isn't that cool? So that's a fun little example that I have. My next one is doubles. What to do when comparing them, okay? So this will pose a problem eventually. I want to show you what the problem is. So let's add 10 0.1s together, okay? And then we'll print it. Doubles.cpp. So eventually I'm going to make a double D and I'm going to print it like this. So now I need, what's it called? IO manip for set precision. And let's make a double D, started at 0, and 10 times I'm going to add to D equals D plus 0.1, right? I'm going to add 10 0.1s together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to, oops. And then I'm going to print D. All right? Then I'm going to print D. Take your guesses as to what might happen and why I'm showing this to you. This seems innocuous, right? Let me show you. Drum roll, please. It is not 1.0. It is 0.9999. It didn't work. It didn't give us exactly 1.0, did it? That is because floating point numbers, doubles, are not perfectly precise. They have a certain number of digits of precision, and that's all they get. Some numbers cannot be represented exactly inside of the space that a double has to work with. So some information gets lost with doubles. It's not an exact type. So what would have happened if you checked if D was exactly 1.0? This would have given back false, even though you added 10 0.1s together. You see that? So you really wanted this to be true, but it wasn't, and it's not going to be. The moral of this story is when you are using doubles, you should never, ever check for exact equality. Never, ever. Instead, what you need to do is check to see if a number is very close to the one that you wanted it to be, okay? Because that will get away from, or that will allow you to work with this imprecision. Okay, that's what I'm trying to say. So if you're expecting a number to be 1.0 and you want to do something if it is, then you better check if it's close, like if it's between 0.9 and 1.1 or some other range that is small, yet finite, okay? Because that would have let it be true, okay? So the trick is to always check and see if the number is close to where you expect it to be. You never check for exact equality. Don't do that. So don't do that. Instead, what you should be doing is seeing if it's very close. So see if d minus like 1.0, the absolute value of that, see if that's very small. 0.0001, something like that. That will check if it's very close on the number line to the number that you wanted it to be. Okay? That is what you should be doing. Okay? So that is just something I want to warn you about, and it is very, very important to not do it wrong. Okay? So make sure to compare properly, and then you won't have any issues. All right, so what you want to do is, instead of what we were doing with strict equality, see how d is equal to 1.0, don't do that. Instead, do and check absolute value, which is f abs, and so I need cmath of d minus 1.0. See if that's very small. Okay, that's what you want to output. Boop. Oops. Because this one's false, and the other one's true. See that? That's what you want to do. Okay, next example. Let's do a bigger grade calculator, right? So given another grade as a percentage, print A, B, C, D, or F, all right, within these ranges, the normal ranges. So I want you to try this while I come up with my own version, okay? So grades. Grade calculator.cpp. So cout enter grade as a percentage. I don't know, double grade, cn grade, and then we want to compare, right? With it, if it's within these ranges. And so the ordering is always the least likely one first, right? Because usually the bigger number first. So we're going to see if it's an A, and that should fix it, okay? That should make it all work. So if grade, you don't even need to check because maybe you got extra credit. If grade is greater than or equal to 90.0, then you know it's an A, right? Otherwise, if grade is greater than or equal to 80.0, if it wasn't this, then we're trying this one. And so that's how I know it's between 80 and 90. You see that? But not including 90, because if it was including 90, it would have hit this one. You see that? That's the trick. And so then this is the pattern. Then we'll do B, and then it's just a bunch of else ifs at that point. It's C, D, and then else for F. It's this ordering. Okay, you see how if this is not true, we know it's not an A, so we try all these. But if it's greater than or equal to 80 after that, we know it's between 80 and 90. If that one's false, we know it's between, and this one's true, we know it's between 70 and 80, because this one was false, this one was true. You see how the opposites of these conditions allow you to infer things about them, the things that come later. And so this is the right order to do it correctly, and you'll get the right output. And so if the grade is like 95.5, it's an A. If it's 80 exactly, or 80.999, it's still a B, because this is not true, and it tries this one, and it is. You see how it will fall through and work? Right? So I encourage you to try some of these options and understand how the code is executing. Okay? That's very important. Okay. Let's see here. Some more examples. Next example. This is probably the coolest one for these slides. Let's make a guess the number game. All right. So let's pick a random number between 1 and 100, and so we'll just store that as like n or something. And so maybe it's like 55. And then we're going to ask the user to make a guess. And so their guess maybe is like, I don't know, maybe they guess 75 or something. And then we tell them based on their guess and the number that we're not telling them yet until they get it, if their guess was too big or too small. So in this case, we'll tell them that their guess was too big. You should guess smaller. Okay. So let's try and code this. We'll notice that there is a problem. Dun, dun, dun. And that will lead into the next set of slides. Guess.cpp. So I want a random number. C stood lib. I want a random number that changes when I call the program again. So C time. Seed the random number generator. And now I'm off to the races. So let's get our random number, int n. Let's be between 1 and 100. So that is going to be n equals rand mod 100. So now it's between 0 and 99. And add 1 to make it between 1 and 100 now. Okay. Inclusive 1 and 100. And then we want to keep asking the user for a guess, right? So we'll make their guess as well. So cout, enter your guess. Cn guess. And then we'll see how close the user's guess was to our random number that we're asking them to pick and guess. Okay? So we'll see if it was too high, too low, or just right. So if the guess was bigger than the number n. If that was the case, then they guessed too high, right? So cout too high. Guess lower. New line. Okay. Otherwise, maybe the guess was too low. Guess was smaller than the real number. This was too low, guess higher. And then otherwise, else, cout, you got it. Because if it's not less than and it's not greater than, it must have been equal to. Yay. There we go. So that's the program. Guess the number program. Oops. Enter guess. 50. Too high, guess lower. And then the program ended. So it just forgot about the number that it was having me guess. And so if I run it again, it's not the same number, of course, because it's random each time. So we don't want the program to stop here, right? We want it to keep asking for guesses while I still haven't gotten it. We want our program to keep going. And sadly, the only thing we know how to do at this point is to just copy and paste our code that we have right now 1,000,000 times. So we could do this a second time, so now we have 2 guesses. Yeah, well, now we have three options at a guess. And that's, I can double that. Now we have 6 options. Let's give like, I don't know, let's give 12 options, why not? So I'll double that once more. So I'm just copying and pasting this code 1,000,000 times so that it'll keep giving me the opportunity to guess. Okay? So 50, too high, guess lower. And then it goes on to the next one, the next set of all these. Enter a new guess. And it keeps the same numbers. That's nice. Okay, guess lower, 25. Ooh, too low, guess higher. 35. Ooh, guess higher, 45. Oh man, too low, guess higher, 47. 48. It must be 49. You got it. And then it still asks me for guesses. So, oh man, that's not very useful. Maybe one thing you can do is have it stop the program when you get it right. We could add an exit that stops the program. Whenever you get it right, you can add that to every else statement, which gets ugly, but I mean, okay, we can do it. So 6, that'll make it slightly cleaner. It'll stop the program if we ever get it right. 50, 75, 65, 70, 67, 66, yay. And then it stops the program with exit. But still, this is super ugly. Like, I have to figure out, I have to guess how many times the user is going to make a guess. The user can keep pressing 50, and eventually the program's not going to allow any more guesses. Like, the user's going to stop it. So that's no fun. We would like the program to keep going as long as the user hasn't gotten the number. Do you see that? No amount of copying and pasting is going to do that for us. Oops. So that's an issue with this code that we can't quite fix yet. And so I want you to think about that. But it's a fun example nonetheless. All right, so let's guess the number. Please study it. And then finally, let's check how we're doing here. Finally, I want to give you one last example that is very useful to know how to do. So I want to show you, and I want you to try it first, if you can, to translate this program here with some variables filled in for just anything. Translate it to a flowchart diagram to see how it's going to execute. Okay? So first, the first line of code is A, and then that always continues, and then it's always this big if else, and then the very last thing is always J. You see that? So this entire if statement, I'll do it with you, is first it has to check its condition, because that's whether it knows to do the body or the else statement. So if B is true, then it does C, and then it's done with the whole if else. So it moves on to J at the very bottom here. J. See that? If B was false, then it tries the else. It runs its body, which first checks D, right? It runs the if else, and then the I. See how to read this? So it first checks the D. If that's true, it does the E. And then no matter what, once it's done with this whole thing, this if else, it does I, and then it's done with the whole thing, and it continues on to the J. You see how I'm reading that? Definitely come to office hours if that's confusing. I know I'm going a bit fast, but there's it's a bit weird looking no matter what, no matter how long you stare at it. So that's that, and then there's an I that leads to J, like that. Okay? So if D is false, then it tries this one, tries F, to see if it either runs this body or this body. So it does F. Hey, are you true? If so, we're going to do G, and then we're done with the whole thing. We can move on to I and then J, of course. And if we're not true, if we're false, we're going to run the else, which is the H in my example. And then the whole if else is done, so we can continue on to I, and then the whole else is done, and we can continue on to J. Okay? Whee! So that's the flowchart. Definitely ask me about that if that is at all confusing, but this is where I want to get you. I want you to be able to understand how code is going to execute in this way, okay? Because otherwise you're just looking at a program and not really understanding it, right? I want you to understand it. One way to get that understanding, the final thing that I want to show you today, is a very, very, very useful resource. It's called C++ Tutor. It's a website. You go here. And what it lets you do is enter some code, okay? And you can enter any code. It doesn't let you give input to the code, so you have to hard code input. So we're going to modify our existing program. But I'm going to show you what's going on here. So let's modify the grade calculator program so that we can see how awesome this is. So let's go to, where's my grade calculator program? Here it is. Let me copy and paste this whole darn thing from my terminal into here. Did it really not copy and paste? Darn. Are you gonna let me? Come on, you can do it. Alright, if that doesn't work, what can I do here? I guess I can get out of all this. Whee! Alright, this is definitely gonna let me copy and paste it now. Terminals are fun. The one thing this won't let you do is get input, so let's just hard code a value for the grade. We'll be like double grade equals, let's make it 75.5 or something, so we can see how it's going to output the C here. And what this does is it shows you how your code executes. line by line. It kind of makes the flowchart for you in a sense, but it's really, really useful to see how your code is executing. So you type your program, you hard code any input, because it doesn't work like that, and then you click Visualize Execution. And what it's going to do is it's going to give you a little video, essentially. It'll let you see all the frames of that video of how your program is going to execute. So here's where it starts, right? It starts on this line. So here's the main function. Grade doesn't have a value yet, but it's about to get one, so I can click Next. Bam. Now it holds 75.5. And now it's going to show you exactly what line it's working on. That's this red arrow. And what's going to happen, right? So this line is checking this condition. Next. Oh man, it was false. So now it's going to try this condition. Next. Oh man, that was false. Next it's going to try this condition. Oh, that one was true. So it goes into its body and executes the whole thing. Output C, it shows you the output right here. Sorry, it's small. And then we're done with the program, because that's the whole if else if else. Only one ever gets run. So it returns 0, and that is the end of the program. Do you see how useful that's going to be for you? I encourage you to take advantage of this website as much as you can for as many programs as you have time to. It shows you exactly how they're running, how they're executing line by line. Okay? That's really helpful as you're learning the language. So yeah, I think that's everything that I wanted to say. So please yell at me if you have any questions, and I will see you in your lab for this week. So I'll go and record that video now.